Stepping into the future, folks. That's what we're doing today. A deep dive into quantum computing. And you know what? These research excerpts, especially that quantum computing paper, really make me think the future is closer than we think. Like, way closer.
It's like science fiction coming to life, right? But it's not fiction anymore. These quantum computers, they're already outdoing the regular ones, at least for certain tasks.
Right. 2024, that seems to be the turning point. So for this deep dive, we're going to really unpack that. How big of a deal is this? And what does it mean for, actually using this stuff?
Well, imagine you're trying to simulate a molecule. Really complex, like for designing new drugs. A normal computer would be like using an abacus to do, like, advanced calculus. Quantum computers, they completely change the game.
It's like trading in that abacus for a supercomputer, right? But then this paper, it also gets into the challenges.
Yeah.
Error correction, that seems to be a big one. What's the deal with that?
Oh, absolutely. Imagine your supercomputer, but it's on shaky ground. Even a tiny tremor can mess up a quantum calculation. Error correction, that's all about protecting against those tremors.
So that's where logical qubits come in. I saw that in the paper. Sounds like a big deal.
It is. A logical qubit, it's not just one qubit, but a whole team of them working together. Like, think backup generators. One fails, the others keep things running. That's what makes them more stable, more reliable.
And we're actually seeing progress. That's amazing. The paper mentioned Harvard and QuEra. They've got this 48 logical qubit system. And the error rate, just 0.5%, that's crazy good, right?
It's huge. Think about it. That's like writing a whole novel on a roller coaster and only having a couple of typos. It tells us we're on the right track to build those bigger, more reliable quantum computers.
Speaking of big players, IBM keeps popping up in this paper. They're really leading the charge, wouldn't you say? Especially with this new quantum Heron processor of theirs.
IBM, they're definitely a force in the quantum world. Their Heron processor, 133 qubits, that's a big jump in performance.
3 to 5 times faster than the previous one, the paper says. What's the secret sauce? They mentioned something called tunable couplers. What even are those?
Basically, think of them as tiny instruments. They let you control how the qubits interact. It's all about fine-tuning the connections to get those really accurate and efficient computations. That's how Heron tackles those complex problems so much faster.
So back to our drug discovery example, that kind of speed boost, we could be talking about going from years of research to a breakthrough in a few months.
Exactly. And it's not even just about speed either. IBM, they're trying to make this technology accessible with qiskit 1.0. That's their new software platform.
So they're not just building the supercar, they're building the road for everyone to drive it on. That changes everything, doesn't it?
It really does. Qiskit, it's like a bridge between the regular computers we use and this whole quantum world. It means a lot more people can actually use this power.
Okay, but with this power, we've got to talk about the potential risks. The paper, it brings up this threat to our encryption methods. That's kind of unsettling, right?
True, it's a double-edged sword. It could revolutionize cybersecurity, but also break the encryption protecting our data right now.
It's like giving everyone a skeleton key. Exciting, but yeah, a little unnerving. They talk about this Shor's algorithm. That seems to be at the heart of this whole encryption issue. Can you break that down for us?
Sure, imagine trying to find one specific grain of sand on a beach, and all you've got is a magnifying glass. That's what it's like for a regular computer trying to crack current encryption codes. Would take practically forever. Shor's algorithm, it's like giving quantum computers X-ray vision. They can find that grain of sand so much faster.
So it's not just brute force, it's using quantum mechanics to their advantage.
Precisely. That's why you see governments and everyone else scrambling to develop what they're calling post-quantum cryptography.
New codes that even these quantum computers can't crack. Like something out of a spy movie, honestly. But what does that mean for, like, the future of cybersecurity? What will our digital locks even look like in this quantum world?
It's the big question, and it's one we need to figure out now to be ready for a future where quantum computers, they're just everywhere. We can't fall behind.
Definitely not.
Yeah.
But hey, this paper, it's not all doom and gloom encryption scenarios. It gets in some really cool potential applications for this stuff, like across all kinds of industries.
Oh, yeah. Honestly, we're just scratching the surface of what might be possible, revolutionizing how we discover new drugs, designing totally new materials. The possibilities are kind of mind-blowing.
So we're moving past just ones and zeros.
Right.
We're talking real changes to like medicine, materials science, the whole 9 yards.
Exactly. And the paper actually gives some really specific examples that show what this could look like.
So moving beyond bits and bytes, we're talking about tangible changes to medicine, material science, and beyond.
Right, real world stuff. And the paper, it actually gives us some specific examples. It's pretty cool.
Let's hear it. What kind of changes are we talking about? I mean, it's not like doctors are going to be prescribing qubits instead of pills, right?
Not quite. Okay, so think about it like this. When they design new drugs, it's all about understanding how different molecules interact. But those interactions, crazy complex, even for the most powerful computers we have now, like trying to map every single star in the universe, but by hand.
Right, a completely impossible task. So
Yeah.
that's where quantum computers come in, with their ability to work on a molecular level.
You got it. They can look at those interactions, analyze them, even predict them with a level of detail that just wasn't possible before, and so much faster. We're talking about finding new drug candidates in like days or weeks instead of years and years of research.
Now, that's what I call progress. And this isn't just limited to healthcare, right? The paper also mentions some potential in material science. What's the deal there?
Oh, huge potential. Imagine like building materials from scratch, literally atom by atom, and you can give them the exact properties you want.
It's like giving engineers a molecular 3D printer. The possibilities are insane.
Right. We could have these crazy strong but super lightweight materials for like spacecraft or building materials that last practically forever.
So what's the timeline on this? When are we going to start seeing this stuff in action?
Well, it's still early days, but the progress, it's moving so fast. The paper, it mentions IBM. They want to build a quantum computer with 1 billion gates by 2033.
2033, that's like right around the corner. And what does that even mean, 1 billion gates?
It's about the processing power. It's going to be insane. And IBM isn't even alone. There's this company, QuEra. They're aiming for a 10,000 qubit system by 2026.
Wow, okay, so they're not messing around. But what does that actually mean for us? What kind of problems could we solve with that kind of power that are like completely impossible to solve now?
That's where it gets really mind-blowing. We could have true AI, something that actually surpasses human intelligence, or finally crack the code of the human brain, understand things like Alzheimer's, Parkinson's, all these diseases that are still such a mystery.
We're talking about potentially solving some of the biggest problems facing humanity. I mean, the paper even touches on the possibility of fusion energy. That's always been the holy grail, hasn't it?
It has. Clean, unlimited energy powered by the same stuff that makes the stars shine. And who better to figure out how to harness that power than a computer that basically speaks the language of the universe,
Fusion energy, it's always felt so far off, but now maybe not so much. But, okay, let's bring it back down to Earth for a second. Even with all this progress, quantum computing, it seems pretty niche. I don't see everyone having a quantum computer in their home anytime soon.
Yeah, probably not anytime soon. Personal quantum computers, that's still a ways off. But that's where this idea of hybrid systems comes in. The paper talks about that a bit. We're not talking about replacing the computers we use every day. It's more like, how do we use the best of both worlds?
So quantum computers, they become like specialized tools working alongside our regular computers.
Exactly. You could use your laptop for everyday stuff, like browsing the web, checking email, whatever. But then when you need to do something really complex, something that would take a normal computer 1 million years, that's where you tap into the quantum power.
So it's like having a team of experts. You've got your general practitioners, the classical computers, and then for those really tough cases, you bring in the specialists, the quantum computers. That makes a lot of sense.
It does. And it makes this whole quantum thing a lot less intimidating, a lot more accessible, even in these early stages. And that's huge because that accessibility, it's what's going to drive even more innovation.
It's like we're building the tools, but we're also building the workshop, making sure everyone can come in and start experimenting, trying things out.
Right. Because who knows what we'll discover.
It's incredibly exciting, all this potential.
Yeah.
But like with any powerful technology, there are going to be challenges. Ethical considerations, especially.
Yeah.
And this paper, to its credit, it doesn't shy away from those.
True. Big power, big responsibility, right?
Go ahead.
Quantum computing, this is definitely a case of that.
It really is. Big power, big responsibility. And we're talking about a technology that could completely change, well, everything. So let's talk about those ethical things. The paper doesn't shy away from the potential downsides.
It doesn't, and we've got to talk about them. Like, we already mentioned how this could crack encryption, right? But what happens when this isn't just theoretical, when anyone can get their hands on this kind of power?
Yeah, that's a big way. I mean, imagine a world where you basically can't have insecure data anymore.
Yeah.
Sounds great, right? But then what if it's used for, the wrong reasons? What about our privacy then?
Exactly. It's a balancing act. We need safeguards. We need to make sure this is used for good. That's why this whole post-quantum cryptography thing, it's so important. We got to be ready for a world where our current security, it just doesn't cut it.
It's like we're building a digital fortress, but the attackers, they're getting stronger faster. But encryption isn't the only thing, right? The paper mentions jobs too. Like, could all this lead to, people losing their jobs?
Right. And that's a real concern. I mean, we're talking about computers that can do things faster, better than humans ever could. So yeah, some jobs, they might become obsolete. And that could lead to problems, economic inequality, all of that.
It's always the trade-off, isn't it?
Yeah.
Advancement comes with growing pains. So how do we make sure everyone benefits from this, that no one's left behind?
The paper, it really stresses education.
Yeah.
You've got to prepare people for this, give them the skills they need. And not just the tech skills either, but like how to even think about this stuff, how to navigate this new world.
So it's not enough to just build these amazing quantum computers. We have to prepare society for them, right? Make
Yeah.
sure everyone has a chance to be a part of it.
Exactly.
Yeah.
And that takes everyone working together, governments, businesses, educators, everyone. We have to talk about this stuff, figure out how to make it work for everyone.
It's a team effort, for sure. Well, we've covered a lot today, haven't we? The crazy science, the potential, the challenges, and of course the ethical stuff. It's a lot to wrap your head around.
It really is.
But if there's one thing to take away from all this, from this whole deep dive, it's that quantum computing. It's not just about the technology itself. It's about what we do with it, the choices we make. Because those choices, they're going to shape the future.
No pressure, right.
Right. But hey, that's what makes this so exciting. So as we wrap up here, I want to leave you with this. We're on the edge of something big, something world-changing. And the question is, what role are you going to play in it? Think about it. Thanks for joining us for this incredible deep dive, and until next time, keep exploring.